So cadets, in last grade, we discussed about the buffer solution, types of buffer solution, acidic buffer and basic buffer. We also know how acidic and basic buffer solution is prepared, what are the physical properties and application of buffer solution. Today, we have to discuss about the buffer action and how buffer solution maintain its pH. How buffer solution maintain its pH. That is known as mechanism of buffer solution. Mechanism of buffer solution. Now see, what is meant by buffer action? The process or the property, best way you can say property. The property of buffer solution to maintain the pH constant by the addition of small amount of strong acid or strong base is known as buffer action. Is known as buffer action. अरे जो बफर सोल्यूशन है इसमें थोड़ा सा स्ट्रॉन्ग एसिड या स्ट्रॉन्ग बेस ऐड करने के बाद में भी अगर उसकी पीएच कांस्टेंट रहती है तो उससे ही कहते हैं बफर एक्शन. Then question arises, how buffer solution maintain the pH constant? So let us consider in each case, in case of acidic buffer as well as in case of basic buffer, we add first acid or say base. At that time, how buffer solution maintain the pH? That is known as mechanism of buffer solution. So the property of buffer solution to maintain the pH constant by the addition of small amount of strong acid or strong base is known as buffer action. Let us consider the mechanism of acidic buffer solution. Acidic buffer solution कैसे अपने pH maintain करता है ये हम पहले देखेंगे. You know that acidic buffer means the buffer solution having pH less than 7. Less than 7. And how it will be prepared? Last period में हमने देखा था. When we add weak acid and salt of strong weak acid and strong base. Salt of weak acid and strong base. Then the acidic buffer solution can be obtained. Let us consider weak acid CH3COOH and salt of that weak acid with strong base. अगर हम NaOH के साथ में strong base के साथ में acidic acid लेते हैं तो क्या तैयार होगा? सोडियम एसिटेट CH3COO. CH3COO. So acidic buffer is prepared by dissolving weak acid and salt of weak acid and strong base. It is known as acidic buffer. One of the examples is, let us consider CH3COOH and it is mixed with CH3COO. It has a fixed pH and that is less than 7. Less than 7. Now, how this pH is maintained? First case, let us consider हम इसमें थोड़ा सा strong acid डालते हैं and let us consider that strong acid is HCl. That strong acid is HCl. You know, HCl dissociates as H plus and Cl minus. So here, whatever the HCl which dissociates as H plus and Cl minus, when it is added in this CH3COOH, this buffer solution, what happens? The concentration of added H plus ion in the product side increases अगर हम ये H प्लस आयन इस साइड में डालते हैं तो ये कॉमन आयन H प्लस का कॉन्सेंट्रेशन बढ़ जाएगा। अकॉर्डिंग टू ली-चाटलर्स प्रिंसिपल क्या होगा? According to Lee-Chatter's principle, when the concentration of a particular ion in product side increases, then reverse reaction will be favored. कौन सी reaction होगी? Reverse reaction will be favored. So when these H plus ions are added in this solution, the concentration of H plus ion increases. So whatever the added H plus ion, they combine with this CH3COO minus and reverse reaction is favored and to produce undissociable CH3COOH. Undissociable. So, ये जो added H plus ion थे, ये added H plus ion CH3COO minus के साथ में combine हुए, तो H plus ions पहले जितने थे, उतने number of H plus ion remains constant. Isn't it? So, if the concentration of H plus ion remains constant, then pH also remains constant. Very simple. So, in this way, when we add the HCl, strong acid, then the pH of this bubble solution remains constant. Now, case second. If we add a small amount of NaOH, NaOH is a base. You know, NaOH dissociates as Na plus and OH minus. Na plus and OH minus. Now what happens? If we add this in product side, whatever we added OH minus ions here from the base, added OH minus ion from the base, combines with this H plus ion from the buffer solution as the buffer solution. So H plus and OH minus combines and produces water molecule. तो product side में water की quantity बढ़ गई, solvent की quantity बढ़ गई. That means the concentration of H plus ion in product side decreases. What happens? According to Lee-Chatter's principle, when the concentration of a particular ion in product side decreases, reverse reaction will be favored. Reverse reaction. And hence, as soon as what we produce, forward reaction takes place, as soon as water molecule produce, this CH3COOH is more and more dissociated in forward direction and produces again H plus ion. So whatever the concentration of H plus ion, that should remain constant. If the concentration of H plus ion remains constant, pH remains constant. Because what is pH? It is nothing but the negative logarithmic base 10 concentration of H plus ion. तो H plus ion का concentration चाहे आप एसिड डालो या बेस डालो, बफर सॉल्यूशन में सेम रहेगा. And in this way, buffer solution maintain the pH. This is in mechanism of acidic buffer. Now, see the mechanism of basic buffer solution. Mechanism of basic buffer solution. Buffer action क्या कहा था? क्या कहा था? Buffer action. The property of buffer solution to maintain the pH constant by the addition of small amount of strong acid or strong base is known as buffer action. और ये जो मेंटेन करने की टेंडेंसी है उसे हम कहते हैं mechanism of buffer solution. Let us consider a basic buffer solution. What is basic buffer solution? The buffer solution having pH greater than 7. Greater than 7. It is known as basic buffer solution. And how it is prepared? It will be obtained by dissolving weak base and salt of weak base and strong acid. Salt of weak base and strong acid. Let us consider weak base NH4OH and salt of that weak base with strong acid is Cl, so that is NH4Cl. So overall NH4OH and NH4Cl, this is a basic buffer solution having pH greater than 7, but it is fixed. Now let us consider, first we added small amount of strong acid, say HCl. You know that HCl dissociates at H plus and Cl minus. And whatever the weak base from the basic buffer solution, it dissociates as NH4 plus and OH minus. Here, NH4OH dissociates as NH4 plus and OH minus. What happens? When we add this H plus ion from acid, this H plus ion combines with OH minus ions from the base, from this buffer solution, and produces undissociable water molecule. Here it produces water. That means the concentration of OH minus is decreases for a while. And you know, according to Leach-Atlas principle, when the concentration of a particular ion in product side decreases, forward reaction is taking place. Forward reaction. So when this OH minus ion concentration decreases, this NH4OH again and again dissociates and produces NH4 plus and OH minus to keep the concentration of OH minus ion constant. तो OH minus ion का concentration constant हुआ, it indicates that pH of that buffer solution also remains constant. See here, whatever the H plus ion from acid added, this combines with OH minus ion from the weak base of buffer solution, water molecule will be produced. So solvent is in excess, concentration of OH minus ion decreases, and therefore whatever the water molecule produces, it, so according to Leach-Atlas principle, NH4OH is more dissociated, and to maintain the concentration of OH minus ion constant in the solution to maintain the pH. Now second case, if we add little amount of strong base, let us consider that strong base is NaOH. With NaOH dissociates as Na plus and OH minus. What happens? If this Na plus and OH minus is added in the buffer solution NH4OH, which dissociates as NH4 plus and OH minus, the concentration of common ion OH minus increases. Hence, as the concentration of OH minus ion increases, according to Leach-Atlas principle, reverse reaction will be favored. Whatever the excess added OH minus ion, these are combined with NH4 plus ion and produces undissociable NH4OH. अभी added OH minus ion NH4 के साथ में react हुए, NH4OH तैयार किया, तो इसमें कितने OH minus ion रहे? जो शुरू में जितने थे उतने ही रहे. That means the concentration of OH minus ion remains constant. As the concentration of OH minus ion remains constant, pH of that buffer solution also remains constant. And in this way, by the addition of small amount of strong acid or strong base, there is no change in the pH of buffer solution.